Hi, grade 8. So we're moving on to our topic 1.3. So this is still under the basics of pretty much grade 7, which you should know. So this video is going to be on topic 1.3 and 1.4. So topic 1.3 is comparing fractions. Now again, a really important thing for your future in maths, but basically fractions can only be compared when you have the same denominators. Now that makes a lot of sense, because if you look at example 1, which says which fraction is larger, 3/5 or 4 out of 7. Now that's literally like I buy a pizza and I cut it into 5 slices and you can eat 3. Or I buy a pizza and I cut it into 7 slices and you can eat 4. Well, the moment you're cutting into 7 slices, you're cutting into more slices. So the slices are smaller. But you're getting 4 slices as opposed to 3. So does that now make it bigger because you've got more slices but they're smaller slices? So it's very difficult to compare, which means we need to have the same denominators. So basically we need to convert 3/5 to a fraction and 4/7 to a fraction where they have the same denominators. Now this is the idea of the lowest. Now it doesn't have to be lowest, but lowest is easiest. The idea is, can we pick the lowest common denominator, which I know you've heard of 5 and 7. Now it doesn't have to be the lowest, because all you're doing is comparing. So as long as it's a common denominator, that's fine. So if you're ever struggling, you can just multiply the two numbers together. Otherwise, you can think about it a bit. So the multiples of 5 are 5, 10, 15, 20. Now none of these 7 goes into. So I can just keep on going until, what do you know, 35, which is 5 times 7. So in this case, 5 times 7, which is 35, is the lowest common denominator. Now we're going back to our idea of creating equivalent fractions, because whatever you do to the denominator, which in this case is timesing by 7, you must do that to the numerator if you are trying to create an equivalent fraction. So 3 times 7 is 21. Now 7 times 5 will give me 35, so 4 times 5 will give me 20. Now don't forget, if you're creating an equivalent fraction, you have to multiply the top and the bottom by the same, because that means you're effectively multiplying by 1. Now which fraction is larger? Well, there we go. So the answer to the question is 3/5 is larger. Now, just because it's really nice to start learning notation, although I know you've seen this notation before, I could have said 3/5 is greater than, that's a symbol, 4/7. So both of those are acceptable ways of answering the question. Okay, let's go on to another one. Arrange the fractions from smallest to biggest, which would be ascending order. So basically I have denominators of 7, 9, and 3. So denominators of 7, 9, and 3, well 9 and 3, that's easy. They have a common denominator of 9, but that doesn't work for 7. So what I would do is just start listing the multiples of 9. Why? Because it's the biggest number. So I pick the biggest number to list the multiples of, because that's probably going to be the toughest for things to go into. 3 is much smaller, so it'll go into lots of things, but 9 won't go into too many. So if I just start listing 9, 18, 27, none of these are divisible so far. 36, none of them divisible so far. 45, not divisible by 7. This isn't looking good. 54, not divisible by 7. 63, 63 is divisible by 7. That is 7 times 9. So again, if you're struggling, you can just multiply the denominators together. Now here I don't need to say 7 times 9 times 3, because 3 automatically goes into 9. So actually it's just 7 and 9 that I was actually worried about. So basically I need to convert 3/7 to a fraction out of 63. I need to convert 4/9 to a fraction out of 63. And I need to convert 1/3 to a fraction out of 63. And then I can compare them. So if I ask myself, 7 must be multiplied by 9, so 3 must be multiplied by 9. And 3 times 9 is 27. So next one, 9 must be multiplied by 7, so 4 must be multiplied by 7, which is 28. And lastly, 3 must be multiplied by 21, so 1 must be multiplied by 21. And so finally, I can tell which one's the smallest. So this fraction here, 1/3, is the smallest, which means arrange in ascending order. Now just be careful, it said arrange these fractions. So I'm not going to arrange my converted fractions, I'm going to arrange my questions. So 1/3 was smallest, then 3/7, which is equivalent to 27/63, and then 4/9, which is equivalent to 28/63. So just make sure that you answer their questions with the original fractions. Right, and that's pretty much the idea of comparing fractions. So what is our summary? First of all, find the lowest common multiple for all the denominators, because that forms your lowest common denominator. Make equivalent fractions so that your denominators are the same, so that then you can compare. So convert each fraction to an equivalent fraction with that denominator, and then compare. So just make sure you hit pause and write down that note so that you can study from it in future. Once you've done that, you're going to try just a couple. So this is exercise 2. I will save exercise 2 as a PDF when I post this video into Google Classroom. So just have a look at these questions. They should take you quite quick, because you're just comparing these fractions by making them into equivalent fractions with the same denominator. Once you've done that, you can carry on, because we're now starting exercise 1.4. 1.4 is about converting fractions. So the last basic skill we need before we can actually work with fractions is, can we convert between mixed numbers and improper fractions? Now the good news is your calculator can convert for you. The bad news is that your calculator is only as smart as the person programming it, and so we're going to have to also just look at how do you use your calculator. So let's just talk quickly about example 1. Convert the following. Now I've put this in color because what do each of these numbers mean? That means you have 4 wholes. So that means you have, I don't know, 4 cakes, 4 whole cakes, if I was to draw them. And then you have 2/3 of a cake. So then you have 2 pieces in the 5th cake out of 3. Now they're wanting you to convert this to a fraction, obviously, out of 3. So how many thirds do you have in total? Well, the idea is you have a 4th cake, and all of these pieces of cake are divided into 3, and because you have 2 pieces, that would be 2/3. So there we go. Now, how many thirds do you have? Well, that means I need to go and take every single one of these 4 wholes, and I need to divide each of them into 3 pieces. So how many thirds, basically, how many 3 pieces are there in 4 wholes? So there's 4 wholes, and there's 3 pieces per whole, which is 12. So there's 12 thirds in 4 wholes, and then 2 extra pieces. So that gives me the fact that I have 14 thirds if I'm looking at 4 2/3. Now they would have taught you in primary school the trick of saying if you have 4 2/3, you multiply these two together. So you multiply 3 and 4, and then you add 2, which is exactly what I've done here. But I'd like you just to understand why. Why am I multiplying 4 times 3? Because I'm saying I had 4 whole cakes, and I divided them each into 3 pieces. So how many pieces do I have in total? Well, I have 4 cakes of 3 pieces, 4 times 3. And then I had 2 extras left over. Right, let's just quickly talk about your calculator for a second. If you put on your calculator and you push 4, and then you push the button that looks like this, and you push 4 2/3, do yourself a favor and actually do that on your calculator and see what you get. So if I do this on my calculator tells me, so if I push that button and then I put in the 2 and I put in the 3, my calculator tells me 8/3. Now that's not what we worked out as an answer. So what is your calculator doing? Your calculator is seeing this 4 as a number, and it's seeing this fraction as a number. And if you have 2 numbers next to each other, they're assuming you're multiplying. So they're saying 4 times 2/3, whereas 4 2/3 means 4 and 2/3. So your calculator isn't doing it properly. So you must not do that if you're using your calculator. What you must do is you must use the button. So if you push the Shift key and then you push the button that has this in it, it'll actually use the little yellow function at the top of that button, which actually looks like that. And then you can go and put in your 4, put in your 2, and put in your 3, because then your calculator is viewing that as a mixed number and not as two numbers multiplied by each other. So very importantly, if you're going to put a mixed number into your calculator, make sure that you use this button. It's shift and then the fraction button will get you that button. Okay, now B is the opposite. Can you convert between what we would call an improper fraction and a mixed number? So basically what this means is you have 23 pieces in total, and each of these pieces represent 1/6 of a whole, because each whole is divided into 6 pieces. So each whole equals 6 pieces. So for every 6 pieces you would have 1 whole. So my question would be, if 6 pieces equal 1 whole, how many 6 pieces go into 23? How many 6 pieces go into 23? Now if you think about it, 23 isn't divisible by 6. Now 24 is 4 holes. Now I don't have 4 holes because I don't have 24 pieces, which means I must have 3. So 3 times 6 would be 18. So 18 pieces would amount to 3 holes. So what does that look like if I just draw a pizza to represent this? Now this is not going to be my best division into 6 pieces, but anyway, let me actually try this a bit better. So there we go. That's probably it doesn't look very even, but you know what, I'm drawing freehand. So that would be 18 pieces if you count them up. 6 pieces, 6 pieces, 6 pieces. 18 pieces would make 3 holes. So this is 3 holes. Now if you have 18, how many left over? Well, 23 minus 18 would be 5 pieces. So there are 5 pieces out of the 6 in the 4th cake that you have here. Okay, now if you put 23 over 6 into your calculator doesn't convert an improper fraction to a mixed number for you. So you have to know how to convert an improper fraction to a mixed number, and then you can check on your calculator. The good news is we actually hate mixed numbers. So you are very rarely going to be transferring from an improper fraction to a mixed number. You are more often than not going to be doing mixed number to improper fraction, which your calculator can help you with. Okay, let's just try a couple of examples. So convert the following: 3 and 2/5. Well, that means you have 3 holes. If each of these holes was divided into 5 pieces, that means you'd have 3 sets of 5, which would be 15. And you have 2 leftovers. So that means I would have 17 over 5. What was the shortcut again? The shortcut was just saying 3 times 5, which is our 15. Add our 2 extras, which is our 17. Question B, 37 over 7. Okay, well, how many times does 7 go into 37? Well, 7 times 5 would give me 35. So if we had 35 pieces, we would actually have 5 holes, because each of these cakes would be divided into 7 pieces. And so you would have 7 pieces in the first cake, 7 pieces in the second cake, 7 pieces in the third, 7 pieces in the fourth, 7 pieces in the fifth, and this would be 35 pieces because of 7 times 5. So there are 5 whole cakes. Now you don't have exactly 35, you have 37. So you have 2 pieces left over in the next cake. So 5 and 2/7. Okay, now the only thing we need to add in now is what happens if there's a negative, because this kind of tends to flummox people. Now if there's a negative, so what if there's a negative? This negative just means the entire number is negative. So what I'm going to do is I'm going to completely ignore that negative, and I'm simply going to look at 2 and 4/7. And I'm going to convert 2 and 4/7, and then I'm going to say, well, it's negative 2 and 4/7. So what does this mean? This means you have 2 holes, and each one of those holes is divided into 7 pieces. So 7 pieces in 2 holes means 14 pieces. And how many extra leftovers do you have? 4. So 2 times 7 is 14, plus 4 is 18. So you have 18 pieces if each cake was in 7 pieces. And the negative is completely ignored. We never use the negative in converting, because then we start to say negative 2 times 7 plus 4, and that gets us the wrong answer. So we completely ignore the negative and we simply just put it next to the fraction. Exactly the same in question D. We completely ignore the negative, so here's my negative. And now I'm going to convert 43 over 6. So how many times does 6 go into 43? Well, 6 times 7 would give me 42. So if we had 42 pieces, we would have 7 wholes, because 6 pieces in 7 cakes would make 42 pieces, except we have 43. So there's 1 leftover piece out of 6 in the next cake. Now, again, the negative gets completely ignored. It actually just gets brought down into the next line. Great, and that's converting. So our last thing for today, so just to summarize this lesson, was copying down the notes of 1.3, doing exercise 2 of comparing fractions, then copying down the notes of 1.4, and finally exercise 3, can you convert the following to either a mixed number or an improper fraction? Then I will post the memos as well, and you can mark them from there. And then we're finally ready with the basics done. We can start adding and subtracting. Well done.